Hey guys, how's it going? It's Engineer It, and it's been a hot minute since my last update concerning R2. So today, I thought I'd talk a little bit more about the legs and how I plan to get R2 to actually move around. Specifically, let's talk about his shoulder movement, how he plans to kind of rotate to his 3-2-3 positions, as well as his center leg and how I plan to get his middle leg to kind of come in and out and be able to put him in that 3-leg mode. So on top of the leg discussion, we'll also talk a little bit about some of the hardware as well as the assembly that's going to go into it. During the making of this video, I am currently actually building up the assembly for his leg and performing all of the animation for him. To give you all a sneak peek of what's to come in a future video, let me show you guys this guy right here. So this is actually the shoulder assembly for R2's leg. So when he has his legs kind of rotate in and out to create that 3-2-3 motion, that's what the shoulder hub here is. So the leg will actually be mounted to this side right here, and this will actually go into the body, where these 4 bolts here would actually mount to the body frame, and our motors would sit inside of here, and there would be a set of gears coming at a 90-degree angle that would connect the motor to the shaft that would actually drive this motion of the leg. And you can probably see what kind of sandwiched between these two parts is the bearing. So this is actually going to hold most of the load of the leg, just so that we're not getting any unnecessary stresses on the actual coupler itself or the body frame. It'll also help kind of create this really smooth motion that you're seeing here. Like, you can look closely, you can see it's fairly easy to rotate this in any orientation I want. So when it comes down to business, it'll be relatively easy to move his legs. And that's about it. So more to come on that guy pretty soon. Anyways, before I get into the CAD, I want to show you guys something really cool real fast. So let me take a look here. And I have my first shipment of Pololu motors. So this guy right here is actually one of the motors that's going to be driving the shoulder for his leg movement. So if you look pretty closely, you'll see this black little cap right there. That is actually the encoder, so that'll actually provide all the information of its position, velocity, and that kind of stuff, so I can actually go in and create a control system to drive this motor. This is the output shaft, so it's a typical D shaft. You might not be able to see it that well, but that will allow me to effectively mount this to the gear head to create that 90-degree effect I talked about to actually drive the leg motion. So pretty exciting to see the motors coming in now. Everything is slowly coming together, and I'm very excited to get started there. So in addition to all the motors and everything coming in, I've also had all the hardware come in to build up both the legs and the center leg assembly. So that would be this stuff all back here. You probably can't see it that well. Let me see here. Yeah, right there. See that? This is just a whole cabinet just dedicated to all the screws, nuts, bolts, you name it, that is going to go into building up these leg assemblies. So very soon, you'll start to actually see animation built out for R2. But yeah, more or less, that's the big updates from a hardware perspective. So I'm getting extremely close to actually building up all the animation pieces, and it's pretty exciting to come to that. Without further ado, let's go ahead and jump right into the CAD. And I'm going to go ahead and try to explain the operating principles that go into driving both the 2 legs on his sides as well as the center leg that will be going up and down. So let's go ahead and get right to it. Okay, so this is the leg assembly for R2. So let's go ahead and just start with the top here and then kind of work our way towards the foot. There's a lot to talk about today, so bear with me here. Okay, so this top assembly here, we have the motor that's going to be driving everything. So this is that Pololu motor that I was showing earlier. So it's connected to a pinion that then connects to a gear at a 3-to-1 gear ratio at a 90-degree angle. And what happens is this shaft that is fixed relative to this gear comes all the way through into this red coupler into the leg. So this shaft is fixed to this coupler. So when this coupler rotates left or right, or however you want to define it, this gear would rotate with it. Now, what's also interesting here, which may be a little bit harder to see, are these 2 shafts right here and right here. So these 2 shafts are actually fixed to these frames here that are connected to the motor. And what these 2 shafts do here is they are fixed to this gear right there. So this gear is actually a belt drive gear. So what happens is this belt drive gear is fixed relative to the frame of this. So we'll call this green piece as well as this gray piece the body frame. So whenever the body moves, this moves with it. This red coupler is part of the leg frame. So whenever the leg moves, this red coupler moves as well. So what happens is as this gear rotates from the motor, these two shafts right here will not rotate in the body frame, but as this coupler rotates, the coupler will rotate around the shafts. So what happens is as the motor rotates these gears here, these shafts will remain fixed in this body frame, but this coupler here will actually rotate about these two shafts. So the two shafts are remaining fixed, and they're mounted to this gear head here. So as this leg rotates 30 degrees in this direction or 30 degrees in that direction, the belt that is mounted to this belt drive here is going to come through the leg out to this other set right here. So this is the other side of the belt drive, which is mounted fixed relative to the ankle. So what's going to happen is relative to the body frame, this belt drive is fixed. But relative to the leg frame, these belt drives are rotating. So what's going to happen is when we remove this, the belt is going to pull on this belt drive here. So if we were to move the leg left or right, the ankle is going to rotate with it, kind of like this. So what that does is it allows us to use one motor to perform two pieces of animation, a rotation about the shoulder here and a rotation about the ankle. It'll also be delivered at a very consistent rate. So let's say the shoulder up here is rotating at, let's say, 5 degrees per second. So too will the ankle. So hopefully that clears up how the actual leg motion is going to be working. So as we kind of traverse our way down, we get to the rocket assembly here. I'm still doing a little bit of modeling here, just trying to clean it up, but let me explain how this guy works. This is by far the most complicated piece of animation for R2. So the way this works is there's actually two motors involved. There is a small servo motor, which is this red guy back here, as well as a linear actuator, which is this guy right here. So what happens is basically this servo motor is going to rotate in this direction, basically pulling the top half of the rocket right here outwards from R2. At the same time while that's happening, in order to keep the rocket level and pointing downwards, this linear actuator is going to effectively extend itself to keep the rocket parallel and level as it moves outward. In order for this effect to occur, we need to move some parts out of the way to create space for the rocket. So this piece right here in gray needs to actually move out of the way in order to allow clearance for the rocket. So what we have here is a special fulcrum assembly. So if you imagine this part right here is the linkage that's directly connected to the servo motor. What happens is as this leg rotates upward, carrying the rocket, this part of the leg moves downward, pushing down on this yellow part of the fulcrum, which in turn moves this green linkage right here. Now what this green linkage does is it effectively takes this gray part and moves it upward and out of the way of the rocket. One thing I will be doing is I'll be installing a spring down here, so once this piece right here begins to return to its zero position, the spring will effectively push on the fulcrum and bring this gray part back down to the position it needs to go. So this is more or less a high-level understanding of the animation that drives the rocket for R2. One additional little piece here is I'm actually going to be cutting out a small hole back here to feed fog tubes through. So what I'll be doing is I'll be having a series of orange LEDs inside of the nozzle here, as well as the outlet to a fog machine. So whenever the rocket comes to its full out position, it'll actually be shooting out smoke with an orange color to it to kind of simulate him about to take off. So as we continue working our way down the leg here, we reach the ankle. So as I said before, there is this belt driver here, which is connected via belts up to the shoulder belt driver. This will effectively enable the ankle to rotate at the same rate as does the shoulder, creating a consistent animation for the leg turn. I'm still working out a few kinks to make sure that it's easy to assemble and easy to take apart when needed. The last bit to talk about for the leg is the drive assembly here. So this is the drivetrain for the feet. This is effectively what will be giving the power to R2 to make him go forward or backwards, or to turn, or whatever sort of motion he's doing. So the way this works is this giant red part here in the middle is the chassis where effectively everything mounts to. So if we start with the motor, there's a small yellow piece here that allows the motor to be mounted and creates a small belt drive system right here. There will be a small belt that will connect from the motor to the actual drive shaft. The drive shaft has a series of wheels that will be set screwed into a shaft right here. These drive wheels are able to be set screwed into this drive shaft here, so we're actually able to get power into the wheels. To keep the drive shaft level, we have these two mounted bearings on both sides right here that allow the shaft to remain level as there is being power delivered into the drive wheels. Now on the other side here are just 4 rubber wheels that are basically just freely rotating with a series of mounted bearings here to keep the drive shaft level. So from a high level perspective, this is more or less how the drivetrain for R2's legs work. Alright, so now we're moving on to the central leg assembly. So whenever R2 folds himself backwards about 30 or so degrees, his center leg needs to come out and effectively create that third contact point. So fortunately, unlike the leg assembly, the center leg assembly is pretty straightforward. So if we take a look at this guy, basically we have the center leg here on a freely rotating ankle bearing with freely rotating casters near the bottom. So really, the leg itself is very straightforward. There's no fancy electronics going through it, no fancy assemblies, very short and to the point. However, the actual part that's creating the animation is a little bit more complicated. So the idea is we have these 2 pylons that are mounted to the body frame of R2. They are mounted at the bottom with these screw holes. So the way this works is we basically have a Pololu motor that's mounted to a gear end right here. This gear end has this gear rack that runs up the length of one of the pylons. So as the motor rotates, it basically travels up and down this gear rack. To keep the center leg level, we have 2 redundant features put in place. So this crossbar here effectively allows the pylons to stay put together as the leg translates up and down the assembly. Additionally, I have these 4 casters here that allows the center leg to travel up and down the pylons. So really, all that's happening is when this gear is rotating, it's basically pulling the entire leg up and down the pylon while these casters and crossbars keep the leg not only centered, but keep the pylons from wanting to open and bow outwards and inwards. So it creates a very stable linear actuation using a rotary motor. And that's more or less how the center leg assembly for R2 works. If you recall in my last video, I talked a little bit about the slip rings right here that I was going to be using for the head turn assembly. So one thing I need to do for these slip rings is I need to install all of the heat insert so I can actually thread in the set screws that will be mounting this together into 2 pieces. Once I do that, I could have one of the big parts of the head turn assembly finished, and then I can integrate that into the main body frame of R2. So real quick, let's go ahead and swap over to the workbench here and just real quickly go ahead and install some heat inserts into some various parts here.
We got Death Star, 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 we got Death Star. And you know that we got it, Death Star.
Well, that was a lot easier than I expected. So you may be asking yourself, why am I installing heat inserts into these plastic parts? The reason these heat inserts are so important is because you can't have metal set screws, or even just metal screws in general, coming into contact with the plastic. Those threads will just rip out the plastic, and then you can't have any sort of mate. So these heat inserts are little bits of brass that you could heat up with a soldering iron and then actually install it into the plastic, and it'll melt the plastic down. And once it does that, it'll create a nice thermal hold. So once that hold is in place, you now have these little spots across your 3D printed part you can now screw metal parts into. So it's a very effective way of getting your 3D prints to behave like real metal parts. So let me just go ahead and show you real fast some of the parts here that I've done. So this right here is the center X-frame for the head turn assembly. So you'll probably notice these brass parts in here, and if you look really closely, you'll probably notice the threads inside that will allow ourselves to put screws inside of. So this will create an effective mating surface for the other components of the head turn assembly. Another good example is this guy right here. So this is the slip ring. So if you look pretty closely, you'll see all of the little brass inserts that are installed. So that's about it there with the heat inserts. Now that I have all of the heat inserts installed into the parts that I need, the next big step is to go ahead and start assembling everything. So in the next episode, I'll go out into the workshop and actually start to build up these parts and assembling everything together. Thank you all so much for watching today's episode. I hope you found it not only informative, but also entertaining. If you like what you see, go ahead and click the subscribe link down below. If you're interested in following my story a little bit further, you can go ahead and check out both my Twitter as well as my Instagram. I'll have links for both of them posted below. So I'm actually about to start my final semester of school here next week. I'll be getting my bachelor's degree in aerospace engineering, so it may be a little bit until I post the next episode. However, I'll be sure to give you all updates if any new developments come across these next couple of months. In the meantime, thank you all so much once again. I hope you all have a great weekend, and I'll see you all in the next video now. Y'all go ahead and stay frosty, alright?